Okay, today we're going to go over the Unit 7 review, questions number 1 through 5. They're just asking us to simplify. So we have all of our exponents, sorry. So this first one, I'm going to ignore this second one for a moment. Look at the first one. I have this 3 exponent on the outside, so I need to distribute to every single term on the inside. So that means I'm going to have 9 to the 3rd power. I'll have my t, and when I try to distribute this 3 with the t, there's already an exponent there. So that means I multiply. So 3 times 3 will give me 9. And then and the same thing, 3 times 5 will give me 15. So that takes care of the first parentheses. Let's do it again with the second one. This time I'm distributing the 2 exponent. So I will have -2 raised to the 2nd power. I will have t raised to the 2nd power, and again with my n, there's already an exponent there, so 2 times 2 will give me 4. So let's go ahead and work out the 9 to the 3rd power, which is 729. And then I will have t to the 9th and my n to the 15th. And then when I do -2 to the 2nd power, that becomes a +4. T to the 2nd, n to the 4th. Okay, this is multiplication, so I can do this a couple different ways, you guys. I'm going to rearrange and put my coefficients together, and then I'll put my like bases together. Makes it a little easier to see what we're supposed to do with our exponents. So 729 times 4 will give me 2,916. T to the 9th times t to the 2nd, it's multiplications, and my bases are the same, so I add my exponents. I will get t to the 11th, and then n to the 15th times n to the 4th, again, add your exponents, and I will get 19. So this is my final answer for number 1. Okay, let's go on to number 2. Again, I have an exponent on the outside. None of my bases are the same on the inside, so just distribute the exponent. Again, when I try to distribute, I already have an exponent there, so I'm going to multiply. So 5 times 3 will be 15, and then 4 times 3 will be 12, and I'm done with number 2. Okay, number 3, again, I'm just distributing. Again, it already has an exponent, so I'm going to multiply. 8 times 4 will give me 32. And there's my answer for 3. On number 4, again, I'm distributing the 0 to every base that I have inside my parentheses. So I will have 3 to the 0 power. I will have x to the, again, multiplying 7 times 0, which is 0. Y to the 6 times 0, which is 0. 2 to the 0. In the denominator, x to the 0, and then y to the -1 times 0. And we know that anything raised to the 0 power is 1, so this would be 1 times 1 times 1 over 1 times 1 times 1, which comes out to be 1. Okay, number 5. Again, I need to distribute the exponent first, so that means I'm going to have 3 to the 3rd power, x to the 4 times 3, which is 12. In the second one, I'll distribute, and I'll have x to the 6 times 1/2 is just 3. So the 3 to the 3rd power, I can multiply out, which is 27. X to the 12th times x to the 3rd, remember we're adding them, our exponents, so 3 plus 12 would be 15. And here would be my final answer for number 5. Okay, number 6, you are trying to figure out what exponent is missing right here to cause us to have this for our answer. Well, if you guys will realize the 1 over x to the 4th power, that is the reciprocal of x to the -4th. So really, if we look at this, we're going to have x to the 5th times x to some power equals x to the -4. So if I'm multiplying, remember the law is I'm adding my exponents. So if I can set this up, 5 plus, I'll put an n for number, equals -4, well, let's just solve for the n. So get rid of my 5 by subtracting. This is gone, leaves the n. -4 minus 5 gives us a -9. So the exponent that's missing right here is -9. All right, same thing on number 7. Again, I'm missing an exponent here. I need the whole entire thing to be 13. So right now I have 5 to the 3rd times 5 to the 5th, which is going to be raised to some power, which is going to equal 5 to the 13th, right? Okay, again, so we know we're going to eventually add these exponents to get the 13. So again, I'm going to set up a little problem. I will have the 3 plus something is going to give me the 13. All right, well, let's get rid of this 3. And that way, this something, sorry, let's put an n here for number. 13 minus 3 is going to be 10. So we need this to come out to be 10. Well, right now there's 5, and if this is going to be an exponent, remember, an exponent raised to an exponent, I'm multiplying them. So what times 5 will give us the 10? Well, of course, it's going to be a 2. So my answer for number 7 would be 2. Right, number 8, it looks like we have a division problem, so I'm going to rewrite this. So all I'm really doing is kind of pulling our like bases together and pulling everything else apart, just again to make it a little easier to see, kind of like when I regrouped on the multiplication problem. So coefficients, I've got 16 divided by 4, which will just give me 4. I have r to the 3rd over r to the -1. Remember, when it is a division problem, I'm going to subtract. So I'm going to have 3 minus a -1. Well, if we do our keep, flip, change, so a -3 plus 1 will give me a +4. So my r's, I will have r to the +4. Okay, let's try the 5s. The t's. I've got a -5 minus a I've just got a -5 minus 2. So a -5 minus 2, again, if we do keep, flip, change, that ends up being -5 plus -2. So in that case, we will end up having t to the -7. And then, of course, we cannot keep our answer with a negative exponent. So the negative exponent, we need to write the reciprocal, which means we're going to flip it over, right? So I'm going to have the 4 and the r to the 4th in the numerator, but in the denominator, I will have 7 to the, t to the 7th power. There's number 8. Okay, number 9. We have a little of both. We have multiplication here, and then we have division going this way. So let's look at the multiplication first. So again, I'm going to rewrite. I have my coefficients together. I have my x's together. And I have my y's together. So that will give me -8 times 2 will give me -16. X to the 1st times x to the 1st, remember? x to the 2nd times x to the 1st. That will give me x to the 3rd. And then y to the 2nd times y to the 3rd will give me y to the 5th. So in my my numerator up here, I've got -16 x to the 3rd, y to the 5th. Okay, let's see what we have in the denominator. I'll do that one down here. I'm going to distribute this 3 to every term, so I will have 4 to the 3rd power. X to the 3 times 3 will give me 9, and then y to the 3rd. So this is the only one we have to figure out right now. So 4 to the 3rd power will end up giving me 64. Then I have x to the 9th, and then y to the 3rd. Okay, so I'm going to write that up here. 64, x to the 9, y to the 3rd. So again, we can rewrite that I'll pull it apart like I did on number 8, but I need a little bit of room. Okay, so if we rewrite it, I'm going to have the coefficients together. I will have my bases of x together. And I will have my bases of y together. And now, negative 64 divided by 4, that's going to end up with a negative 1/4. X to the third over x to the 9. If we subtract 3 minus 9 will give me x to the negative 6. And then y to the 5th over y to the 3rd, that will be 5 minus 3, which will give me y to the 2nd. Okay, it's looking good except for, again, we have a negative exponent. So we need to move that term only. This one right here needs to go to the denominator. And then because I have something in the numerator, do I actually have to keep the 1 there? No, but I need to keep the negative sign there. So I will end up with negative y squared over 4 and then x to the 6th. Let me write that here. Negative y squared over 4x raised to the 6th power. And here's my answer for number 9 then.